Jake Zanny. Today I'm going to be talking to you about Chapter 5, Force. The fundamentals in Chapter 5 are Newton's 3 laws.
And if they're equal to each other, that means that velocity is terminal. So
his first law states that if there is no external force on an object, then the object will not accelerate. That means its velocity will not change. So therefore, if this is sitting still and there is no external force on it, it will not move. Or if it's already moving and there's no force causing it to accelerate, the velocity will not change. So, if delta V equals 0, then the change in force also equals 0.
You can also just say real quick that the net force on the object would be mg
Delta F equals 0, then there is no acceleration. The units of force are measured in newtons. The measurement of acceleration is meters per second squared. All right. Newton's second law states that the sum of all forces on an axis equals ma. Ma stands for mass times acceleration. Mass is measured in kilograms. Acceleration, again, is in meters per second squared.
So to find the terminal velocity, we can divide by v.
Newton's third law states that for every force an object experiences, there is an equal opposite force that reacts upon it. So if I'm holding this pen, the force applying up by my hand is canceled out by the force applying down due to gravity. So it states that every force on an object, there's an opposite force on it that cancels it out to 0. If you break force down, there are several different types of forces in physics. First off is gravitational force, which equals mg, the mass of the object times the force of gravity, which is 9.8 meters per second squared. That equals the weight of an object. That is measured in newtons. So if you have a box that weighs 2 kilograms, to find its weight, you multiply that by 9.8 meters per second squared, and you get 19.6 newtons. That's the weight of the box. FRK is kinetic friction. Kinetic friction is the friction on an object while it is moving. So if I take this book and I slide it across the table, the friction that it experiences while sliding is the kinetic friction. The static friction is the friction it experiences while it is not moving. So if I'm trying to push the book and it doesn't move, that is the static friction. So T stands for tension.
The force of it. Then you just slide away.
Tension is the force in a string or a wire or anything like that that an object experiences. Dropping your phone and having the headphone wires catch it is a common modern day example of tension. If the phone is just standing still when it falls, tension is just equal to mg. If the phone is moving, you draw a free body diagram. You have mg going down and tension going up. You then solve sum of all forces in the y-axis and get that equal to 0, or mn. From there, you set up mg minus t equals mn. So mg
Pardon the interruption.
minus ma equals 2. Alright, so in this example, we're just going to cover the tilt angle really quickly. This is a diagram for a pilot during takeoff in a jet. There is a force applied to the right as he's accelerating along the runway, and the force of gravity goes down. This is going to cause a force somewhere. Hang on. This is going to cause a force somewhere in that direction for a net force. After that, the force the pilot feels will be in the opposite direction, so the pilot will feel a force going that way. To find the tilt angle, it's just the tangent of theta equals the applied force over the force of gravity. And then from there you get theta equals the inverse tangent of applied force over the force of gravity. And then that will give you the angle that the pilot feels the net force. And then from there you just do a simple vector. Fg plus Fa equals Fn. Fn is the net force. And then that is applied along the tangent, the angle theta. Now I'm going to turn it over to my colleague Ramsey, who's going to do some practice problems.
Hi, I'm Ramsey Beebe, and I'll be doing some practice problems. Here, if you want to open your book to chapter 5, number 45, we'll be doing the problem with you. So we have 3 connected blocks, all with strings, and a person pulling it at the end. We know T3, and we know all the masses, but not T1 and T2. First, we'll have to solve the magnitude of the system's acceleration. So first, make a free body diagram. Now that we have our free body diagram, we can simplify it to make it one big system. And now that we have our system together, we can do sum of all forces in the x equals max. And sum of all forces in the y equals 0. Now what we learned about tension is you can do T equals ma. So now we have one big mass, so we just do T3 equals M1 plus M2 plus M3. Times A. And And now we know that T3 is 65 newtons, so we can substitute that in. And we know all the masses, so we can add those up, and it's 67 times A. Divide, and we get A equals 0.97 meters per second squared. Now for part B, we have to solve for tension 1. So tension equation is T equals MA. So we can solve for it. T1 equals M1A. And just substitute in the values. T1 equals 11.64 newtons. And now for part C, we have to solve for tension 2. It's the same equation, T equals MA. And T2 equals 34.9. newtons. Thanks for watching, guys, and remember to stay tuned for our next video, chapter 26 on resistance and circuits.
Bye! Oh, that hurt. Please tell me that's not on camera. Tension is the... Oh, please stop. Killing me.
What?
Do you have headphones?
Alright, I gotta go too.